Jordan.
And I'm Roddy, and this is RoboHand.
The idea of our project is to build a robot hand that runs off of a 12-volt DC servo motor. The motor will be connected to an in-bed controller as well as a Wi-Fi connector in order to power the hand. The components that we used to build the fingers were the PVC pipe, which obviously we would need a cutter in order to cut the fingers out. We used a soft flex wire to wire the fingers to the motor so that when the motor runs, it will open and close the hand. We also used eye screws and tape in the fingers and to make sure that everything was connected correctly. We used a 293H bridge, and we actually used a 12-volt DC motor and not the servo motors. The particle photon and the freedom controller, like I said before, is used to send signals to the motor in order to run the hand. We had the 324 op amp and thermistor to have a thermistor override, so when the thermistor is heated, it makes the hand open so that you don't burn your hand.
And some of the problems that we were having with some of the issues with this project, the thermistor placement we were originally going to do on the fingertips, and then we came to find out that that wasn't going to work too well for the project at hand. So we put it on the palm of the hand so we'd be able to get that reading before the fingers get to the point where they would burn. Another problem we were having was finger positions. I couldn't figure out a way to get the fingers to where they would stay in a forward position without bending backwards on us. So we had to come up with an idea to make almost like a knuckle system on the back of it. So that was able to come up with some of our basic problems from the beginning. Another big issue we had was the wireless photon chip. Doesn't necessarily like to connect to most Wi-Fi's, especially if there was a password required or a school password. So we had to figure out a different way of doing that. So as of right now, we have the online chip strictly as an on-off switch, but we do also have it set up when it can connect to a Wi-Fi to where it can also control the hand movements and make the hand wave if need be. All right, some of the screenshots we took. First, I want to show you what the schematic basically is going to look like. It's a very rough drawing, but this is our basic schematic of the system we have at hand. You have the thermistor is connected to the 324 in order to create an op amp, and that's going to allow us to be able to override and put in a signal in case the thermistor does overheat. We have that connecting into our freedom chip, and that's going to also have where the feedback from the motor comes in, as well as either our trim pot, or if we're using the wireless connection. Either way, we can connect to this point here in order to make our hand open or close accordingly. Another piece that we have in here would be the 293 chip. The motor connects to that in order to control the current flow. That gives us a forward or reverse direction based off of what we tell the chip to do. So that's going to be our basic schematic for what we have going on with the system, and I'm going to give you an example now. All right, while that's coming back down, the hand how we have set up right now is on a manual control. So as I hit the thermistor or the potentiometer right here, it'll tell the hand which way to go. And you can see this light's lighting up. That light's telling me which way I have the hand going, whether I have it going in a forward or a reverse direction. The blue light tells me that it's within the window and tells me that the hand's going to stop moving. So, and then you heard her talking before about the thermistor. If the thermistor for any reason overheats, that light's going to turn orange for us to let us know what's going on, which apparently I'm not doing right now. So, but when that does happen, this is a thermistor before there's heat added, and then after there's heat added, they'll come together, and once that happens, there's no longer that window available, and it causes the system to override. All right. This is just to show you when we have a forward high versus a reverse high. When the forward is high, it changes the current. So here you have a forward moving current, and then here you're going to have a reverse moving current. And this is just showing from our feedback The whole moral of this entire project is to drive to a 0 reading. As long as our feedback is running the same line as our potentiometer, our hand is within our window and everything's going to be exactly where it needs to be and there will be no motions needed. All right. And these are just to show the chasing up and chasing down. That's where I have the hand as I was showing before where we can close. Oop, that's the one thing. There we go. Open and close the hand. I think that's about.
And again, I'm Jordan.
And I'm Roddy, and this was our robot hand.